according to Max. Amy Wang. Book 4, Attention Mechanisms. Max was reading a book called How Machines Understand Language. It gave this example. The cat sat on the warm laptop because it liked the heat. Max read it and smiled.
Obviously, it means the cat. The laptop doesn't like things. People and animals do.
Right? That makes sense to us, but how would a computer know? Max tapped his pencil, and that's when Max started thinking about spotlights.
What if each word could look at all the others and decide which ones help it understand?
Max jumped up to the whiteboard and said,
Each word becomes 3 vectors.
He wrote,
Q is query, what I want to know. K is key, what I offer to be matched against. V is value, what I can share if you choose me. To understand a word like it, the model turns it into a query. Then it compares that to every other word's key and collects values from those that match.
He then drew spotlight lines to it from cat, laptop, and heat. Max said,
It uses its query to compare with every key using a dot product to obtain an attention score.
On the whiteboard, Max wrote, score I equals Q times KI. So it's measuring how closely related they are.
Exactly. Who aligns with what I'm looking for? We turn the scores into spotlight strengths, probabilities using softmax.
He added. Max wrote on the whiteboard, alpha I equals softmax, score I. Alpha 1 equals 0.7 for cat. Alpha 2 equals 0.2 for laptop. Alpha 3 equals 0.1 for heat. So now it knows who matters and by how much.
Next, it blends the values using the softmax weights to get the weighted sum, which is commonly referred as the contextual embeddings.
He further explained. Max wrote, Z equals alpha 1 times V1 plus alpha 2 times V2 plus alpha 3 times V3.
This is the updated vector for it. The machine started with a rough guess now. It's smarter, thanks to context.
Max wrote down the full equation and said,
This is how a language model refines meaning, with every word asking, scoring, and blending iteratively.
Attention, Q, K, V equals softmax, Q times K transposed, times V, and
Not just it. Every word runs the same process all at the same time.
Max supplemented. So every word helps build context for the others.
Exactly. That's why it's called self-attention.
Max's whiteboard now shows how self-attention works. 1. Every word becomes Q, K, and V. 2. Use Q to score all case. 3. Turn scores into weights. 4. Blend the V with weights. 5. Get new vectors with context. So it's like every word is listening and every word is heard.
And that's how a computer reads not just left to right, but with attention in all directions.
Max recapped.